The purpose of this video is to visually demonstrate the impact that theory of constraints and optimized flow principles can have on your business. Let's start by defining the framework. Our system is a 1.5 liter bottle filled with water. Our goal is to empty it as quickly as possible. Our performance indicator is therefore time. Our constraint is of course the neck of the bottle, the choke point through which all of the water must flow. The demonstration is done through 3 phases using the same bottle with differences in the flow dynamics following the applications of the POOGI, or process of ongoing improvement. Observe carefully what happens in each phase. First, what's happening in the bottleneck itself, the dynamics of the flow through that bottleneck. Second, what are the dynamics of the rest of the system that is inside the bottle? In the first phase, the bottle is turned upside down to allow the water to flow out on its own. The clock starts when the bottle is turned upside down and stops when the bottle is empty. What do you observe? It takes approximately 20 seconds for the water to flow at a rate of approximately 4.5 liters per minute. Let's look at what happened. First, in the bottleneck, the water has started to flow, but this creates a vacuum inside the bottle. This vacuum caused the flow to stop momentarily and allowed an air bubble to enter the bottle. The air relieved the vacuum inside and caused an equal amount of water to flow through the bottleneck. This process was repeated until the bottle was empty. It is a continuous repetition of a stop-start flow. Second, within the system, the result of this stop-start flow is strong agitation. There is a lot of activity, but it does not increase the throughput. There are many unproductive conflicts, many internal processes that do not add value, and a system that becomes captive to its own internal processes. This is a demonstration of the world of local optima. In the second phase, we exploit the constraint. For example, we are sure that it is always used, no more stop and start. The bottle is turned upside down and then a few turns are applied to generate a swirling movement. The vortex generated allows air to circulate in the bottle while water flows through a swirling spout. What effect does this have? Will there be any improvement? Observe carefully what is happening in the bottleneck as well as what is happening inside the bottle. It takes now around 10 seconds for the water to flow at a rate of around 9 liters per minute. This is double the flow rate of the first phase. What happened this time? First, in the bottleneck, it took a second or two for the water to generate a vortex. This vortex lets air in while water flows through a circular spout. The water and air each have their own path, which creates a continuous, uninterrupted flow through the bottleneck. Second, inside the system. All water particles are aligned in the same direction and create a continuous flow. Everything is contingent on generating a directional flow. This is a good demonstration of the theory of constraints in a physical flow environment. In the third phase, a straw is added to channel the airflow. The bottle is turned over with, inside, a straw in which we have secured the absence of water. Note that the straw reduces the capacity of the bottleneck. The timer starts when the bottle is turned over and the straw released. It takes almost 7 seconds for the water to flow at a rate of 13 liters per minute. What happened this time? First of all, in the bottleneck, the flow rate was ultra fast, stable and without interruption, and more than 3 times higher than the flow rate of the first phase, despite a capacity reduced by the introduction of the straw. We are breaking a belief here that to increase the flow, we must widen the bottleneck. Second, inside the system, the interior is characterized by calm, stability, and the absence of disturbances and pressure. Is it possible to have a great flow in a calm and serene atmosphere? Yes, this is done by doing the right things. These 3 phases illustrate the following lessons. First, the bottleneck remained the same, showing that the theory of constraints is not a process of debottlenecking operations, but a process of increasing flow through the constraint. Second, If you follow the right approach, you can achieve great flow and a calm, serene work environment simultaneously. To do this, you must address the physical flow and human aspects of the business simultaneously. Finally, you can gain a lot of flow without having to invest a penny.